So my name is Midian. Can you please give a brief introduction of who you are and what you do?
Yes, I am an assistant professor at the University of Maryland within the Department of Atmospheric and Oceanic Science. I do research at the intersection of artificial intelligence and weather extremes and climate. Yeah, I think I mentioned my name is Maria Molina, but maybe I
Yeah.
did not.
Mhm. Yeah. So what inspired you to pursue research and how did you get started?
So I originally was interested in extreme weather when I was like 5 years old. That was because I grew up in South Florida and I was impacted by a really strong hurricane. And that storm was a Category 5, which is the highest rating on the Saffir-Simpson scale for hurricanes. And it caused a lot of destruction and devastation in the region that I lived in. And so that sort of inspired me to do weather prediction, especially focusing on extremes. I went to undergrad in meteorology and worked as a broadcast meteorologist for about 6 years. And that included time on national cable news in the city of New York. And during that time, I was really interested in whether or not extremes were changing because it felt like we were seeing more of them. The public would frequently ask questions like, is this the new normal? Are we going to see more of these? To answer such questions, my expertise was more so on predicting them in short time scales. And so I did go to graduate school at Columbia University while I was working full time as a broadcast meteorologist. And during that time, I was able to do some research and I became very interested in research and being able to dive much more deeply into science questions as opposed to sort of the very fast pace of news where you have an extreme event and the next week there's another extreme event and you move on. And so I ended up leaving broadcasting to focus on getting a PhD in climate and extreme events. And then I transitioned into a scientist role at the National Center for Atmospheric Research, and now my position as a professor, assistant professor at the University of Maryland in College Park.
That's great. Can you share one project you're working on right now that excites you the most and why?
Hmm. Um, yes, there are a number of projects I'm working on. I guess I'll talk about the paper I'm currently finishing up edits for. We essentially were interested in these large-scale patterns over North America called weather regimes. And we know that there are these slower evolving patterns that essentially offer predictability for temperature and precipitation over the continent because they're slow moving and persistent and recurrent. So we know they'll happen again and again. It was we're curious about how diverse an individual weather regime could be, and if we could identify useful precursors to better predict them. So we developed a self-organizing map, which is an unsupervised neural network that has a slightly different lattice, essentially architecture than your typical self-organizing map neural networks. And essentially, this lattice enables better continuity in terms of tracking how a weather pattern evolves. And it's allowed us to identify recurring patterns that have higher predictability and I'm currently editing the manuscript that is currently under review in a journal.
Yeah, so that's great. Can you expand on the neural network and how it has helped you through your project?
Yeah, so the neural network helps me because it's a very flexible set of weights that I can tune. And instead of me having to tune them with hard-coded rules or thresholds, I essentially give the neural network data and I specify what means better, right? Like how to organize that data into something that would score better. And so I have to define what that score metric is. And so essentially what we did was we defined the traditional metric that's used for self-organizing maps and added an additional customized metric that we were interested in. So the traditional one is the self-organizing map is essentially tasked with minimizing the distances between types of weather patterns and grouping them into groups that have similar properties. And so that's sort of its metric, how it knows it's organizing them well. And then the next pattern in time would be next to the current group so that it wasn't jumping around the map too much. And so that allowed us to identify pathways that were more common or frequent. And yeah, and so I love neural networks because they're very flexible tools in that way that allow you to sort of identify a problem and specify it in a loss function or a metric, and then train that neural network to look at data and try to optimize that specific metric or loss function.
Yeah, that sounds really interesting. So to expand on like your like experience at the university and research, what skills or habits have been most critical for your success? So, like the point of this podcast is for students who are tuning in, who are interested in technology and doing research, how they can get into the field. So how can students start developing the skills that are necessary to do research and or use neural networks now so they won't have to, so they're ahead of the pack, say when they get to university or their postgraduate life?
Yeah, I guess I'll start with maybe more like professional type habits before jumping into the skill sets that are more technical. So I would say it's probably good to start practicing being self-motivated and looking up how to do things, right? So let's say your professor or boss or teacher or whatever sort of mentor you're working with on a research project or even just in a classroom setting, whatever their expertise is, it's possible that their expertise won't extend to all aspects of neural networks, right? Like, for example, there are neural networks that I might be familiar with, but I haven't used myself in research. And so I think it's being able to tap into the expertise that folks around you have, and then taking initiative and looking up either who you can ask for help on things that perhaps they really are deep experts in to help supplement the knowledge gap in your other setting, or even look up resources online. Right now, we live in this era where we have not just Google search or any search engine of your choosing to be able to find resources. But we also live in an era of generative AI helping us find information or help us, yeah, synthesize information. So I would say also getting good practice with finding resources and yeah, that answer your questions. Otherwise, I would say being very diligent and persistent, I would say. In other words, if you're going to encounter issues in your research or learning process where you're going to encounter information that may be hard to digest or synthesize or make sense of, and it's really important to be okay with that feeling, right? And like maybe you feel a little dumb or like you're not understanding something, and that's normal. And you just go to sleep, come back the next day and look at it again. And eventually you'll notice you'll start to better understand things or yeah, make sense of information that you're learning. And then also just showing up every day. Research and knowledge gains, etc., aren't made in a day. It takes time and consistent effort over time, being able to gain these skills. Otherwise, on the technical side, there's a number of open source resources. I would say making sure you're pretty good at coding with Python. While we do have a number of coding agents out there that are extremely helpful for spinning up, I still think it's important to make sure you understand what is happening with the code and being able to help the generative AI diagnose things at times. Like sometimes it'll give me code that is really slow and I'll look at it really quick and I'm like, oh, it's doing this thing that I know I've dealt with before, and then I fix it, right? And then we get on the same page quicker, right? Like generative AI is a collaborator, and also depends on my expertise. So yeah, so I think yeah, making use of resources, being diligent and persistent, and leveraging all the open source tools out there, especially with an emphasis on Python. But there are textbooks, and I can probably talk for like a week about all the available resources. But if you go to my page for my group, there is a tab for teaching that does have access to an open source PDF where I list a number of different papers and open source textbooks and other resources like GitHub repositories with tutorials where you can go and sort of pick your favorite topic of choosing of interest in machine learning and dive deeper into it.
Mhm. Thank you. And how do you see the industry of neural networks, specifically in your field of research, climate change, changing in the next 5 years for students who are just entering higher education or research?
Oh, okay. Yeah, that's a big question. I mean, I would say anywhere from all kinds of neural network architectures have their advantages and disadvantages. Of course, there's a cutting edge, really large neural networks and custom architectures that have achieved awesome performance, but have only done so because of the availability of really large data sets. So I would say perhaps also focusing on lighter neural network architectures is important, given that if we are concerned about our carbon footprint, being able to train lighter models is important. And one of the ways that you can do that is taking an already pre-trained, really large model like a foundation model, and then leveraging that information with a lighter weight model that focuses on some bespoke or very specific task that you're interested in. And that model can be more lightweight, right? And focus
Mhm.
on the tasks that you're interested in. Um, yeah, otherwise, in terms of where we're going, I guess I would keep an eye on reinforcement learning. It's been around for quite a while, but in terms of climate science and weather science, it seems to be emerging a bit more in terms of its utility for tuning our models, our physics-based models or AI-based weather models. Um, and also, of course, diffusion has been around and continues to be around. And now it seems like these rule-based or type uh, generative models are emerging more and more so because they have more speed compared to diffusion models and even at inference. And yeah, I don't know. I think it's a very exciting time. Being able to have some probabilistic information in a neural network is obviously understood as being really important. In addition to generative properties and yeah.
Thank you. So, on the topic, furthermore, on the topic of neural networks, you do work in the climate sector of research, correct? So, how do you see these
Correct.
neural networks being used in other forms of research, such as engineering or mathematics?
Um, I'm not sure in terms of mathematics, although I think I've seen some headlines where some really challenging problems are being solved with deep learning. In engineering, I will say in my physical sciences neural networks course at University of Maryland, there have been a number of aerospace engineering students that have taken the course and done course projects on things like modeling airflow around certain airplane types and wingspans and things like that. So they're interested in things like drag and so forth. And they have physics-based models that they use, but they're very expensive to run. at high resolution. And so that's a space that neural networks can be leveraged for their problems, and they've been leveraging them for their problems. Yeah, so essentially emulation much more cheaply with neural networks is an easy place to start, and it's something that seems to be universally done across many science and math domains, I guess, maybe.
Yeah, thank you. So now speaking more generally, how do you think students could break into research or like the postgraduate industry before they graduate or enter university or any higher form of education?
When you say graduate, I guess are you referring to high school students?
I'm guessing, yeah, I'm referring to both high school students who have not done research and college students or higher education students who have yet to apply the research they've conducted.
Yeah, I guess for high school students, I would probably focus on being able to research universities that are aligned with their interests and have faculty that they could seek out as mentors. And they are welcome to reach out to those faculty when they are applying as undergrads, right? So I've had a number of undergrads or prospective undergrads reach out and express interest in conducting undergraduate projects. So you can already start sort of setting yourself up for an undergraduate education that not only has the required coursework and your degree of interest, but also has faculty employed there that are willing to take on undergraduate researchers. Regarding at the high school stage, it's a little bit more difficult because to connect with university-based faculty because you wouldn't be at the university and you get very busy with all the courses that you're taking and your timelines, which are super important to keep doing well on so that you can get into a university of your choosing. But nonetheless, I would say trying to find courses at your high school that are aligned with that, and then finding teachers or mentors that can help you take on some small projects, or even looking up tutorials online and taking those. So I will say that's something I definitely did when I was a student is seek out open source resources that maybe even if they weren't directly connected to what I wanted to do, they did help me get my feet wet with some specific architecture or type of model that I was interested in. And that's something I still do as faculty, right? I'll still start exploring a little bit somewhere in that's in a direction I want to go to.
Yeah, that sounds right. So for the final question, what emerging trends or breakthroughs do you think in your field of studies students should pay attention to if they want to enter the respective field of study?
I think diffusion models are certainly a big space in weather and climates because of their generative properties and also their properties that make them steerable or controllable. So there's the domain called guided diffusion, where one can take an already pre-trained diffusion model and guide it towards states that you're perhaps more interested in. So that would be one area that I would definitely pay attention to. I would also pay attention to reinforcement learning for weather and climate, whether it involves placing an agent in an environment and having to make decisions based on weather and climate information, such as, for instance, traffic patterns during evacuation routes for extremes or other such type topics, or even for using another physics-based weather or climate model and sort of tuning the knobs for that. Um, yeah, and then I think also unsupervised learning is really important. So being able to characterize data properties in an unsupervised way where you don't know the answer beforehand is also really important. So I mentioned earlier, self-organizing maps is a pretty straightforward entry level type of neural network. And it sort of is like clustering where you're grouping patterns that are similar. And I think, being able to describe your data richly and understand it well is also important. So unsupervised learning is always going to be important, even though that one it may not be as in the news as some of these other topics.
Okay, great. Well, thank you so much for joining today's podcast. I think the audience would really appreciate your message. And yeah, have a great day.
Thank you.